This video will cover beginner questions regarding the topic of the limit of piecewise function, limits and graphing. This is the first question. fx is a piecewise function where 1 over 2x if x is greater than minus 2 and minus x minus 3 if x is less than minus 2. So, how can we graph this piecewise function? We will start with the graph y equals 1 over 2x first. Y equals 1 over 2x is the same as y equals 1 over 2x plus 0. So y-intercept equals 0 and the slope is 1 over 2, which is rise over run, so 1 up, 2 to the right. So plot the y-intercept and the slope is 1 up, 2 to the right, 1 up, 2 to the right, like this. So graph passes through the origin and this one. So this is y equals 1 over 2x graph. Since the interval of the function is only for x is greater than minus 2, so greater than minus 2, this, we only graph this part and leave a hole at x equals minus 2 because the interval does not include minus 2. The next graph is y equals minus x minus 3. So y-intercept is minus 3 and the slope is minus 1, which means 1 down and 1 to the right. So start with minus 3 and 1 down, 1 to the right, 1 down, 1 to the right, like this. So the graph is this one. Again, the interval is only for x is less than minus 2. This is minus 2. So we only graph this part. Leave a hole at x equals minus 2. Now we can combine the functions together to draw the piecewise function f of x. So this is the hole and graph from here and this one. And this is y equals f of x graph. Number A is the limit of f of x as x approaches minus 2 from the left. So x equals minus 3, minus 2.5, and minus 2.1, like this. The y value is approaching minus 1. The number B is limit of f of x as x approaches minus 2 from the right side. So x approaching minus 1, minus 1.5, minus 1.999, like this. And the y value is approaching minus 1. So the answer is minus 1. And number C, limit from the right hand side is equal to the limit from the left hand side. So the same answer. The answer is minus 1. Number D, when x is exactly minus 2, here, the y value does not exist. Remember, the defined intervals do not include x equals minus 2, so does not exist. This is the next question. F of x is a piecewise function. X squared minus 4 over x minus 2 if x does not equal 2, and 1 if x equals 2. The graph of y equals x squared minus 4 over x minus 2 can be rewritten. So we can factor x minus 2, x plus 2 over x minus 2, and then cancel the common factor. So finally we have x plus 2, but x never equals 2. First, we have to draw y equals x plus 2 graph. start with the intercept. Y-intercept is 2 when x equals 0, and x-intercept is minus 2 when y equals 0. So the graph is like this. But x does not equal 2, so we can make a hole when x equals 2, like this. This graph is very characteristic, so this hole is not that big. Actually, it's very, very small, so you can't see this hole. You can check with your graphing calculator. When you draw y1 equals x squared minus 4 over x minus 2 graph, the graph like this. This one is minus 10 to 10 by the y minimum is minus 10, y maximum is 10. Please change the window. So x minimum equals 1.99999 and x maximum equals 2.00001, and then graph again. You will see the graph like this, and then x-axis, this is 2, and then graph is like this. This x value is 2, so graph is not continuous at x equal 2. Go back to the original. When x equal 2, the y value is 1. This is the final piecewise function f of x. So y equals f of x. Number A, the limit of f of x as x approaches 2 from the left, like this. And then the y value is approaching 4. Number B, the limit of f of x as x approaches 2 from the right, and the y value is approaching 4. And then number C, the left-hand limit of the function and the right-hand limit of f of x is the same, so the answer is 4. And then number D, when x is exactly 2, the y value is 1. That is the answer. This is the next question. F of x is a piecewise function. We can start with y equals x squared graph. So start with the origin, and then 1 by 1, and 1 by 1, 2, 3. Same, the 1 by 1, and 1 by 1, 2, 3. And then draw the graph. The interval is x is less than 1, so start with x equals 1 with a hole and the left part. Y equals 3 graph here, but only x equals 1, so the y value is only this point. The last one is y equals minus x plus 3. Y-intercept is 3 and x-intercept is also 3. So the graph is like this. The interval is x is greater than 1. When x equals 1, then y equals 2, but with the hole, and goes down. Then combine all three graphs together, make the piecewise function f of x. So the first one, this one, and then second one is only 1, 3, and then third one start with 1, 2 with the hole, and slope is minus 1. So this one is y equals f of x graph. Then number A, limit of f of x as x approaches 1 from the left, side. So y value approaching 1. Number B, limit of f of x as x approaches 1 from the right, and the y value is approaching 2. Number C, the left-hand limit is not the same as right-hand limit, so does not exist. And then number D, when x is exactly 1, the y value is 3. This is the next question. Limit of f of x as x approaches 1 from the left equals limit of 2x plus 1 as x approaches 1 from the left. And then put 1 into x, so 2 times 1 plus 1, 2 plus 1, which is 3. And then limit of f of x as x approaches 1 from the right equals limit of x squared minus b as x approaches 1 from the right, and then put 1 into x, so 1 squared minus b equals 1 minus b. The limit of f of x as x approaches 1 exists when the left-hand limit and right-hand limit is same. So the limit of f of x as x approaches 1 from the left side is the same with the right hand side. So 3 equals 1 minus b, and then b equals 1 minus 3. So final answer is this one. This is the last question. Limit of f of x as x approaches 0 exists when the left and the right limits are the same. So we have to check the left side first. So limit of f of x as x approaches 0 from the left equals limit of square root of 4 minus x squared as x approaches 0 from the left, and then put 0 into x, square root of 4 minus 0 squared, so square root of 4, which is 2, and then limit of f of x as x approaches 0 from the right equals limit of 2 to the power of 2x plus 2 as x approaches 0 from the right side, and then put 0 into x, so 2 to the power of 2 times 0 plus 2 equals 2 to the power of, this is 0, then square, which is 4, and then by these two, the left and the right limit are not the same. So limit of f of x as x approaches 0 does not exist. I hope this video has been helpful. If you have any questions, leave them in a comment below and I will address them in a future video. Thank you for watching. Please like and subscribe for more.